Hello guys, in this video we are going to discuss how to solve a system of linear equations using the matrix method. So over here we have a system given, a system of two equations in two unknowns. So we have to solve this system and we're going to use the matrix method to solve it. So first of all, I want to discuss how the matrix method actually works. Okay, so now suppose that you have a matrix equation, okay, A multiplied by x bar is equal to b bar. Now, A is the matrix of coefficients, and x bar is the matrix of unknowns, and b bar is the matrix of constants, all right? So now the objective here is to solve for the matrix of unknowns, which is x bar. And the way you do it is that you calculate the inverse of A, and then you multiply throughout this matrix equation by that inverse. All right, so the inverse of A is denoted with an A to the power of -1. So that denotes the inverse of A. So now we multiply by this inverse throughout this matrix equation. So we say A inverse multiplied by A x bar is equal to A inverse multiplied by B bar. So what we've done here is that we've basically just multiplied by A inverse throughout this matrix equation. Now, A inverse multiplied by A inverse is equal to I, which is the identity matrix. Okay, so now we replace the A inverse multiplied by A with an I, okay, which is the identity matrix. And we multiply this by x bar, which is equal to A inverse multiplied by B bar. Now guys, the identity matrix I, it behaves as the number 1, meaning that when you multiply it with any matrix, you get back that matrix. So in this case, we have I multiplied by x bar. So I multiplied by x bar is equal to x bar because the identity matrix I behaves as the number 1 in matrix theory. So then this means that the next step is as follows. X bar is equal to A inverse multiplied by B bar. Okay? So now we have the solution. That's the solution. So x bar is equal to A inverse multiplied by B bar. And that's the solution of this matrix equation. So basically, this is how the matrix method works. Okay, so this is the method that we're going to apply to solve the given system of two linear equations in two unknowns. All right, so let's go ahead and solve the system using this particular method here. Now, the next thing we're going to do now, okay, is that we are going to write this system of equations. We're going to write it in matrix form, okay, because now it's given in algebraic form. So now we're going to just rewrite the same system in matrix form. All right, so let's go ahead and do so. Let's go ahead and do that. So we've got 4, 2, 7, 8. That is our matrix of coefficients. So the matrix of coefficients obviously is made up of the coefficients in this system of equations. That's 4, 2, 7, 8. That's what makes up the matrix of coefficients. All right, so we've got 4, we've got 2, we've got 7, we've got 8. So that's the matrix of coefficients. 4, 2, 7, 8. And then the matrix of unknowns is basically x, y. It's a column matrix, and it's basically x, y. All right? And then obviously now you have the matrix of constants, which is basically 4 and 6. All right? So you put 4 over there, and you put 6 over here. All right? So that's the same system of equations written in matrix form. So now the objective now here is to solve for x, y, to solve for this column matrix of unknowns. That's the objective. So now, the next thing we're going to do is that we're going to find the inverse of this matrix of coefficients, this 4, 2, 7, 8. So we're going to find the inverse of this matrix, and then we're going to obviously multiply throughout this matrix equation, and then we're going to find the solution. So we're applying this method that we discussed over here. So therefore, let's go ahead and find the inverse of this coefficient matrix. Okay, so we're going to call it A. So let's call this matrix A, all right? So this coefficient matrix here is denoted with an A. So now we're going to find this inverse. Now, to find this inverse, we have to first find its determinant. So we have to find the determinant of this matrix in order to find the inverse. Okay, so therefore, let's go ahead and multiply and find the determinant. Okay, so the determinant of this matrix A, all right, is given by the following. So since it's a 2 by 2 matrix, okay, so this matrix is a 2 by 2 matrix. To find the determinant of such a matrix, you have to do the following. You basically multiply the entries in the main diagonal. So you multiply the 4 and the 8. So you go 4 multiplied by 8 minus the following. Minus 2 multiplied by 7. So you multiply these two over here, and then you minus by the product of these two. That's how you find the determinant of a 2 by 2 matrix. Okay, so we say 4 times 8 minus 2 times 7. Okay, so that's how you basically find the inverse of a 2 by 2 matrix. Okay, you say 4 times 8 in this case minus 2 times 7. All right, so that's basically 32 minus 14. Okay, now the answer to that, of course, is 18. Okay, all right, so there we go. This is now the determinant of the matrix A. So now that we have this determinant of the matrix A, we now want to find the inverse. All right, so to find the inverse, then we do the following. Okay, this implies that the inverse of this matrix A is equal to 1 over the determinant of A multiplied by the following. So you multiply by the following. You interchange the 4 and the 8. So you interchange the entries in the main diagonal. So you put 8 where the 4 is. Okay, you put 8 where the 4 was, and then you move the 4 and put it where the 8 was. So you interchange the entries of the main diagonal. And then you put minuses in front of the rest of the entries. So you put minus in front of 2, and you put minus in front of 7. All right, so that's basically how you find the inverse of a 2 by 2 matrix. Okay, now we have the determinant already. We've calculated the determinant, and it's 18. So basically, what you can do, we can simply just replace this over here with the 18. Okay, so in place of that, we're going to put 18, because that's what the determinant is 18. So then the inverse of A is equal to 1 over 18 multiplied by this matrix here. Okay, so we go ahead and we multiply. We go ahead and we multiply 1 over 18 into the matrix. So that's what we do. We go ahead and we multiply this 1 over 18 into the matrix. So we multiply 1 over 18 by 8 first. Okay, so 1 divided by 18 multiplied by 8, and that gives us the following. It gives us 4 over 9. Okay, that's the first entry there. And then we go 1 over 18 multiplied by minus 2, and that gives us a minus 1 over 9. Okay. And then we go 1 over 18 multiplied by minus 7. and that gives us minus 7 over 18. And then we go 1 over 18 multiplied by 4, and that gives us 2 over 9. So then that is our inverse. That's the inverse of the matrix A. Okay, that's the inverse of the matrix A. And of course, the matrix A in this situation is this matrix here. All right, that's the matrix A. That's the matrix of the coefficients of our system of linear equations. Okay, so now guys, let's move on. So now this basically means the following. Okay, now that we have our inverse, this basically now means the following. Okay, it means that, say therefore, okay, it means that the matrix of unknowns, and of course in this case the matrix of unknowns is xy. So this means that the matrix of unknowns xy is equal to the following. It's equal to the inverse of the matrix of coefficients, which is equal to the inverse that we just calculated, which is 4 over 9 minus 1 over 9 minus 7 over 18, 2 over 9. All right, so it's equal to this inverse here. 4 over 9 minus 1 over 9 minus 7 over 18, 2 over 9, multiplied by the matrix of constants. Okay, so this matrix of unknowns is equal to the inverse of this matrix of coefficients multiplied by the matrix of constants, which is in this case is 4, 6. All right, so we put 4, 6 here. Remember, we are using the matrix method. We're using the matrix, the matrix method that we discussed over here. That's what we're using. If you see over here, as we discussed earlier, you see that x bar, which is the matrix of unknowns, is equal to A inverse times B bar. All right, so we're basically using this. All right, we're using this to solve this system of equations. We've got the matrix of unknown is equal to the inverse of the coefficient matrix multiplied by the matrix of constants. That's basically what the solution is. So now to get the solution, we simply just multiply. We just multiply these two matrices here. We just multiply these two matrices here. Okay, so let's go ahead and do that. Now, if you look at these matrices here, the one on the left is a 2 by 2 matrix, and we're multiplying it by a 2 by 1 matrix. Okay, so when you do that, what matrix or what will the size be? What will the size of the resulting matrix be? All right, first of all, before you multiply matrices, you have to look at if the column of the matrix on the left, if the columns, the number of columns of the matrix on the left matches the number of rows of the matrix on the right. In this case, they match, so therefore you can multiply these two matrices. And then the resulting matrix, it's going to have the following size given by these two numbers here, meaning that it's going to be 2 by 1. So the resulting matrix will be 2 by 1. All right? The resulting matrix will be 2 by 1. If you're multiplying a 2 by 2 matrix by a 2 by 1 matrix, the resulting matrix will be 2 by 1. So therefore now we know that that's what we're going to have. So let's go ahead then and solve it. All right? Let's go ahead and do it. So let's first calculate the first entry of the resulting matrix. The first entry. And the first entry will be in position 1. Okay, that's row number 1, column number 1. All right, it's going to be in row 1, column 1. Okay, and to find it, to find this entry, we have to do the following. To find this entry, we have to multiply the first row, which is this row here. We multiply the first row of the inverse matrix, and we're going to multiply it by this column matrix here. So we multiply these two, the first row and this column matrix here. So that's how you find that, that first entry. That's how you find that first entry. So let's go ahead and do that. So we go 4 over 9 minus 1 over 9 multiplied by 4, 6. So 4 over 9 minus 1 over 9 multiplied by 4, 6. So you multiply this row with this column. And of course, when you do that, you will get the following. Okay, so you say 4, the way you multiply them, you multiply the corresponding numbers. Okay, so what I mean by that is that I mean you go 4 over 9 multiplied by 4. So you multiply the first entry in the row matrix, you multiply by the first entry in the column matrix, and then of course you add minus 1 over 9 multiplied by 6. Okay, and the answer that you get over there is as follows. So you're going to have 4 over 9 times 4 minus the 1 over 9. Okay, minus 1 over 9 multiplied by 6. Okay, and that's going to give you the following. It's going to give you 10 over 9. Okay, so this is going to be 10 over 9. Okay, so that's your first entry. And then your second entry is as follows. Okay, it's going to be in the second row and the first column. Remember, this is going to be a column matrix. It's a 2 by 1 matrix. So that's a column matrix with 2 rows. Okay, so the second entry will be in the second row, the first column. And to get it, you multiply the following. You're going to multiply the second row of this matrix. So you're going to do this. You're going to multiply the second row. You're going to multiply the second row of this inverse matrix, multiply it by the same column. Okay, so that's what you do. That's how you get it. All right, so let's get it. Okay, let's do it. So the second row then is minus 7 over 18, 2 over 9, and you multiply this by the column 4, 6. Okay, and let's go ahead and calculate this. So now you're basically going to have the following. You have minus 7 over 18 multiplied by 4. So you got minus 7 over 18 multiplied by 4 plus 2 over 9 multiplied by 6. Okay, so it's plus 2 over 9 multiplied by 6. So when you do so, when you perform this calculation, you simply get minus 2 over 9. Okay, so these are your two entries of your resulting matrix. So this basically means the following. So this means that the matrix then of coefficients, which is of course the matrix xy, so it's the matrix of unknowns, not the matrix of coefficients. It means that the matrix of unknowns xy is therefore now given by the following. All right, so you put your entries in. So the first entry is 10 over 9, and the second entry is minus 2 over 9. Okay, so that's your entries. Therefore, your solution. So this is the solution of the given system, and you can write it in this way. You can write it as follows. You can say x is equal to 10 over 9, okay, and x, let's go back there, supposed to be ny, and y is equal to minus 2 over 9. And that's basically the solution. X is equal to 10 over 9, and y is equal to minus 2 over 9. And of course, this is the solution of this given system of two linear equations in two unknowns. All right, and of course, to check this, to test it, you can then just take these two numbers and substitute them back in the system here. So you can take those two numbers and substitute them back in the system, put x, substitute the x value where x is, and substitute the y value where y is in the given system, and see if it satisfies the system, and it will. And of course, if it doesn't satisfy, that basically means that you made a mistake somewhere in your calculation. And you must go check your calculations because it should satisfy it. But that's how you basically solve that system using the matrix method. And so this is basically the end of our discussion. And guys, there will be a part 2. I'll post a part 2 soon. Where in part 2, we are going to discuss solving a linear system of 3 equations in 3 unknowns using the matrix method. So guys, thanks for watching the video. And if this video helped you in any way, if my videos help you in any way, please support this channel by subscribing to this channel, liking the videos, and also leaving a comment. Thank you so much, guys. Cheers.